Hey folks, voice test as always. Can you hear me? I'm assuming you can. I'm going to assume I can from here on in. Someone will moan if they can't hear what I'm saying. Also, hi. Thanks for coming along. It's good to see the usual faces / names in the chat. So, good evening. Who we got? Exorcat, Archbishop, Gombos, Hatwolf, Vendetta, Parody. All the regular faces. Always a pleasure to have you here. Now, the only order of the day is tea. So there's a funny story behind this tea today. My youngest boy Jasper heard me yell out earlier on today. He heard me say to Amy, "Amy, you making tea?" And of course she said, "Hell no," implying that I should do it myself. And then my little fella thought he'd be super awesome and go ahead and try and make a cup of tea for me. So what he did was he went and grabbed my Gyokuro and he attempted to do a proper Gyokuro brew by himself without reading the instructions. So he got A for effort and a huge pat on the back for being a self-starter. But brewing the old Gyokuro, particularly from a fresh set of leaves, is a fine art. And it was one of the most disgustingly bitter cups of tea I've ever tasted. So I went through the process of explaining to him what you need to do when you brew a good green. So anyway, this is brew. Well, I had brew number 2 after I explained. And this is brew number 3 of the Gyokuro from that same set of leaves. Because as we all know, hacking without tea is very uncivilized. But thank you, Jasper. I appreciate your contribution. Proud dad, I know. Gotta love him. He was pretty gutted when I took a swig. I was like, mate, I'm sorry to say that is the worst cup of tea I've ever tasted. I'm such a jerk. But it was like seriously bad. It was bad. I didn't enjoy it at all. And because I can't lie to my kids, I'm not just going to go, well, that's lovely, for fear of him doing it again. So anyway, I'm sure next time it won't be terrible. At least it should be better, right? Cooper's Pale, that's not too bad. Got to be happy with that. Do a tea stream to learn as uncivilized coffee drinkers how to... Yeah, right. Yeah, okay. Interesting. A rough day for you, Archbishop. Know the feels, Vendetta. Yeah, he is amazing, hey. Vendetta's met my little fella face to face, so he knows what he's like, and he's a gem. So, hey, Rasta. Good evening, Mongo. Thanks again for coming along. So, slightly different approach today. We are... When I say slightly different approach, well, for the most part, we're actually going to do the same thing. But the main difference is going to be that I'm going to do a little bit less of the what do you think, you give me your opinions, and a bit more of the okay, pay attention, we're just going to bash some code out. Coding dictatorship, exactly that. So how lost am I going to be jumping in at part 5 not having seen the previous parts? Hey Voltage, thanks for coming along, man. I don't think you'll be completely lost because we haven't really written a lot of code, but there may be some background knowledge as to what you are seeing on screen that may be a little bit confusing. So feel free to ask questions. Maybe the people in the chat will help answer. But yeah, I would recommend going through the previous videos to fully get across it. Yeah. Ooh, we've got another follow. I heard the bling. Voltage. Thank you, Voltage. Oof. Brings shame. Saw someone wearing a MongoDB t-shirt at Costco tonight. Oh my god. Have they no shame wearing that in public? I am disappointed. Okay, so before I flick over to what's on screen, what I'm going to do is just quickly explain a little sort of revelation that I had. Obviously the last coding stream that we did, which was the first one, stream number 4, I felt it was really messy, a bit all over the place, and we had a lot of opinions coming back and forth, which was great and all, but I think it really slowed things down. And then off the back of that, once we finished up and I sat down and thought about it and went to bed and my brain worked on things behind the scenes, I sort of woke up and went, you know what, we're going to take a different approach. And I'm going to bash through stuff, hopefully fairly quickly, get to a point where we're able to parse TLV packets in the way that I think would make the most sense, given the fact that we are sort of living in a fairly abstract / loosely typed world. So, welcome back, eighth. Did we say eighth is what we're going to say? Eighth? So yeah, pretty good contraceptive, those t-shirts. Yeah, that's very harsh but fair. Okay, so what I'm going to do basically is I'm going to sit back and drive. I'm going to tell you what I'm thinking. I am going to pay attention to chat. Hey Atari, thanks for coming. So yeah, I think I'm just going to drive it, and if I see a really relevant question or a really I don't know, pointed sort of point, I'm going to go, yep, thanks for that. I'm going to keep moving to get to a point where we actually have the ability to parse stuff. And so what I'm going to do from here is we're going to start with actually extracting one or more packets out of a Meterpreter communication with an existing, like through the existing implementation. I'm going to grab those bytes, and then we're going to drive that in a test app, and we're going to parse those bytes. And I'm going to sort of go from top down. So Peleus, TLDR, you all suck at code. OJ will only take suggestions from me. Yeah, I'm sure that's what I meant. Man, that pause in the music was perfect timing. That's funny. Daily stand-ups on Discord. Okay. Well, good thing is we all suck at code, right? We all suck at code. Okay, so one other thing to mention is... Hang on, where are we? We are changing our background today. We are going to... Where are we? Let me press the magic VMware button. We now have a blue screen behind. I felt like for some reason that's just the vibe. We got a blue screen rather than the Microsoft.NET behind the scenes. We all have a good blue screen, right? Thank you, Gumboss. I thought you'd appreciate that. So, okay, so the first thing that we're going to do is... those two backgrounds are the same. They probably are. All right, so step one, we are going to do some hacks. We're going to hack some stuff. So the reason why I'm going to do this is because what I'm going to do is create a Python Meterpreter. We're going to make it so that it spits some crap out to screen. And in doing so, that's going to dump packets for us. So that's effectively what step one's going to be. So in order to do that, let's go to github.com, rapid7 metasploit payloads. And we're going to go straight to the source. Python Meterpreter, meterpreter.py, raw. So this is the thing that we want, okay, because this is basically the body of Python Meterpreter as it currently stands. So let's go to data Meterpreter, and we'll grab a copy of that. So let's grab meterpreter.py, there we go, there's the source, all good. All right, so here's another thing that behind the scenes I keep track of a bunch of handy little gists, such as this one, which I kind of use in a lot of different projects, and you know, I kind of shove it in little gists so that I have them handy for when I'm out and about. Now this one I use quite a bit, particularly this chunks one, which breaks things up into chunks. And this stuff here that helps me do a bunch of decoding of bits and pieces, which I actually tweaked a little bit today after chatting to Multi. So I'm just going to take these, and we're actually going to drop them in here. Let's do it here. Okay, so I'll probably change maybe these lambdas to, let's go as array, and we'll call this as string. Now the reason I'm doing this is because I'm going to dump the packets, right? So there's a function in here called getPacket. As you can see, we call getPacket, and then we decrypt the packet. Okay, so what I want to do here right now, you'll notice that there's no AES encryption support in Python Meterpreter, which is something that I'm actively working on behind the scenes, but obviously that's not part of this stream. So, hey Barney, thanks for coming, mate. So what I'm going to do here is I'm just going to say, once we've got the packet body, which is basically the entire packet. I'm just going to dump it to screen as it currently stands. All right, so let's go with print. We're going to do it as bytes. Now you'll notice that as array of bytes, it takes three things. It takes the XOR key. It takes, so this XOR is me dumping it out to, actually I don't even need to do that, do I? This one here actually spits things out de-XOR'd, because I use that all the time. But what I might do instead of actually using XOR, maybe we'll call this as XOR array, XOR string, which we probably won't need all the time, but as array, I just want to take the data and dump it to screen. So whatever the data is, lambda d, and actually we'll specify s for size as well. I'll explain what this stuff is doing in just a minute. So what do we want to do? We want to go and we want to take basically the character that we're mapping over, which is whatever C is, and we're going to convert that to an integer. So we want ord of C. We want to format that as hex. So let's do 002x dot format ord of C. So whatever the character is for C in D. Okay, so that's going to go through and convert each one of those to a hex sort of byte array. And then what we want to be able to do is we want to take chunks of a certain amount, which is, so chunks is a lazy evaluator, right? So we want to take all of those chunks and we're going to break them into just 16 byte chunks. All right, and then once I've got those chunks, we're going to join them together with a new line. Now what I might do, given that I'm hacking this on the fly, let's fire up Python 2 here and drop these things in, right? So we're going to need, we don't need XOR, we do need chunks. So let's take that, paste that in there. Oops. What did I do? Did I not grab it properly? There we go. So for example, if we had some data that looked like, let's say map char range 0 through to 255, you can see that D is just an array of all that stuff. Now if we joined it together equals, so here you can see we basically got a string of all the data. That's just me fudging some data together, right? So with D, what I want to be able to do is if I went chunks of D in 16, you see what it should do is, let's convert that to a list because it's lazily evaluated. You can see they're all 16 byte chunks now, with whatever's left over being in the last one. So what I want to do is I'm going to map across these. So this one here, this as array, basically want it. So if we go as array, and we say, we want that data in 16 byte chunks. What does that look like? Sequence item 0, expected string, and list found. So that's obviously not working. So the data that we've got is a string, and we want to map across the string for every that's right. So we need to join this back together. Righto, which is fine. So we join that data back together, and we end up with a single string. And that didn't change anything, did it? So we're taking all of these things here. That should be okay. Okay, if we do this, oops, VIB, that thing there, that's what we want, right? What does this do? Ah. List of those things. Aha. Yeah, okay, that's not going to make any sense, is it? Because we actually want to chunkify each thing. So we don't want to join it there. We don't want to join that at all. That's being silly. Greetings, Kittix. So we are taking each one of those is converted. Yeah, that's basically what we want to do, right? So if we take this, then this will actually make a little bit more sense. List of those chunks. There we go. So you can see we've got each one of these is a list now of 16 bytes, right? So instead of joining those, what we need to do is we need to join them together with commas to begin with, right? So instead of that, we've got all of our chunks. We want to map a join across those. So if we go map, actually no, let's not even do that. Let's go let's call it chunk for chunk in chunks and chuck that in there. Hey Multi, thanks for coming in, bro. So what does Azure do now? There we go. Alright, so you can see now we've got blocks of that with new lines in the middle. So instead of new line, I'm going to put comma new line. And then instead of what we had, let's go print as array D16. There we go. All right, so here we go. We've got 16 byte blocks. We can probably do that as 8 bytes. Oh. Why didn't that behave differently? How many chunks could a wood chunk? That's not funny. So clearly I'm not doing enough with S. I hard-coded it. So there's 8. And there's 16. Okay, so the reason why I want to do that is because it's nice to be able to just sort of dump this stuff out to console easily, right? So let's get rid of this here and we'll put S in. And then down here when we've got as array, we just want to print out whatever the packet is as 16 byte blocks. All right, so that means that every time we get a packet that's come in, we're going to spit it out onto the console. All right. So let's go back to here. Now, first of all, we need to create a payload. So let's go MSFN and payload, Python, Meterpreter, reverse TCP. L host is 127.0.0.1. L port, we'll just stick to 4444. Output to temp met.py. Let's go to the right folder before we do that. All right, so that should spit the payload out to temp.met.py. Take your time, Metasploit. Temp.met.py. So there's the stager. And now we want to go MSF console, and I like to do this on the command line because it's faster. So we want to use multi-handler, set payload, Python, Meterpreter, reverse, TCP, set L host, 0.0.1, set L port, 4444. A couple of settings in here that are worth highlighting actually. So first of all, set exit on session false. That'll keep the listener running behind the scenes. Set Python Meterpreter. Let's just make sure I get that right. Meterpreter debug true, so that we spit debug output out while we're seeing it. And we'll also go Meterpreter try to fork false, because I don't actually want it to fork and run in the background. And then we can go run -J. Let's keep that running. Let's change the layout a little bit here. You guys can see this at the moment. You are binding to a loopback address. That's correct. That's what I want to do. I mistyped. And this is why I like doing things on the command line, because it's very easy to restart MSF in the process. So yeah, I got the 16 hard-coded. Whoops. Yes, but as we know, that only works if you're running get system. Pelias. That's the only caveat there. Okay, so let's just reduce this a little bit. Actually, no, we want to go the other way, don't we? We want it to increase in size. Come on. Okay, so Python temp meterpreter.py. Let's see what happens. Ooh. Why didn't that work? Yes, and now there's actually a, have you noticed that there's no info here? It looks like Python's actually busted. Px pipe grep met.py. Let's kill that off to 5708. Not sure why that didn't happen. I definitely set these correctly, didn't I? Excellent session. Python meterpreter debug true. Meterpreter try to fork. Pretty sure that's what it is. And let's go and have a look at advanced. Python meterpreter debug. Meterpreter try to fork. I gotta say set, don't I? Set. And Python meterpreter debug. Let's do the copy and paste thing to make sure that I'm not fat fingering. This is just so that we spit stuff out of it. Actually, we don't even need to do that because I'm not actually using the debug output anyway. I'm just doing a hard-coded print, so it should be fine. Fedora. Fedora is correct. Fedora with i3. It's definitely Fedora. Now, why is that not actually working? That's really interesting. Something screwy. But at least we can see the meterpreter fork thing didn't actually... Oh, there we go. Look at that. I wonder what that was. So, 258... Oh, crikey. 25893. Let's just kill that off. Here we go. So we do have some packets come in. Whee. Righto. So what I'm going to do is I'm just going to grab the first of these. That one there. Okay, I'm going to take a copy of that. Because this is a packet that we're going to test with. Alright. So as you can see, we're back to where we were before. But I'm going to change some stuff. And to begin with, this is going to scare you a little bit, but this is what we're going to do. Yeah. Oh my goodness me. So, bear with me. I know I'm an absolute madman. All right, so what I'm going to do, just for the sake of getting things going fairly quickly, we're going to create a new project, but this time we are going to create a console app, .NET Framework. We're going to make sure it's 3.5, and all we're going to do is, I'm just going to call it test console .NET 3.5, just to keep it consistent. Oops, 3.5. Okay, test console.NET 3.5. Why you didn't do TLV in its own thing? Oh, that was just us hacking shit together, which is why that was the case. All right, so let's go back to this. Copy that. All right, so what I'm going to go is I'm going to go data, so it's as if it's a packet, equals new byte array. Paste that in there. Come on, format for me. There we go. So we've got a packet now that we can play with, right? And so really what I want to do here is I want to create a new packet out of it. So var packet equals new packet, and I'm going to give it the byte array. And this is just one of the ways that we're going to do it. So we're going to have two different ways. We're going to have we're basically going to have to pull in data off one transport or another. And what I want to do behind the scenes is I want to parse that packet so that we end up with like a TLV structure sort of sitting behind the scenes, if that makes any sense. I can understand if it doesn't. Anyway, so in order to make use of the existing packet, we're going to have to add a reference. So let's add a reference. We're going to add a project reference to metserv35. And then from here, we should be able to specify met.core. So that's going to allow us to create a packet. Now, clearly we don't have the ability to create a packet yet. So we need to expose it. So we're going to have a public packet. So this is the constructor that thing's going to call to begin with, right? So there's the packet that's coming in. Okay, now we know that the packet is going to... What's going on? People having Twitch issues? No? All good? Yep, okay, cool. We'll play on, all right? I'm going to keep on benevolently dictating. Now, at the top level, what I think we should expose, at least from the packet point of view, is the collection of TLVs that exist inside the packet. So what I'm going to have is we're going to have a public dictionary, similar to what we had before. We're going to need a TLV type, right? We haven't got that defined anymore because I've scrapped it. And then we're going to have a list of TLVs, okay? And that's effectively going to be what our TLVs are. We're going to have a public getter and a private setter, all right? So, first of all, we should include generic collections. Now, TLV type is obviously undefined. So let's just go back to our TLV class and we'll go public enum TLV type, and we know that's going to be a uint 32, include the system namespace. Now, we haven't defined any elements in it yet, but the fact that it's there should mean that when we come back here, this should be okay. Now, regardless of the constructor that we use, because there might be other constructors down the track, I'm just going to create a default constructor. In fact, I'm going to make it private. Private constructor. So only this thing can construct it, and it's the default constructor. And it's going to create a new dictionary of TLVs. All right, like so. So this fits the same mold as what we had on the last stream, right? Because we can have multiple instances of TLVs behind the scenes. All right. Another thing that we're going to have, and I think this will probably remain internal, so I'm going to make it private for now, is a packet type. So we've got like a TLV type and we've got a packet type. So I'm going to have a private packet type, which we're going to deserialize sort of on the fly. But that means we have to define it, right? So let's go public enum packet type. Okay, now the packet type stuff is actually, really simple. That's going to be a uint 32 as well. All right, now, so we've got 4 types. There's a request packet, which is 0. I've got a TLV reference off to the side, just so you know. A response packet, which is of type 1. We have a plain request. Now, I don't really know what the difference between these things are, to be honest, and a plain response, which is 11. All right, so they're the different packet types, right? So when we actually get the top level packet, we'll end up with the header, okay? Now, to begin with, we're not going to look at supporting encryption. We will deal with that after the fact. But right now, what we need to do is we'll just handle the cases where we can pull apart a packet that has been not encrypted. And then from there, we can easily add support to encryption on the top. Yeah, no, I'm unfortunately not a savant, my friend. I wish I was. So anyway, what I'm going to do, this is C# syntax just here, by the way. So we've got a public constructor, which means anything outside of this class has to call this constructor. But I'm going to call my inner constructor here so that this line here gets invoked. Now, the reason I'm doing that is because there's a good chance that we'll expose another constructor depending on how things go. And that could literally be handling the case where we're pulling in data on a stream. The packet's responsible for knowing whether more information is required or not. Similar to what we do in the Java version and things like that. So that's a little bit of knowing what's coming. Okay. So From inside here, we're going to extract. We're going to extract the exhort key. Now remember, the exhort key is. We know it's 4 bytes long, right? So we've got a 4-byte exhort key, and we're going to take that first 4 bytes out of, where are we? So exhort key, sorry, the source array is the data that's coming in. Destination array, exhort key, and the length is 4. So that should give us the exhort key, yeah? And then once we've got that, we actually want to go through and iterate over all of the bytes in the entire packet, okay? Now, in order to do that, so what are we going to do? We're going to have a private void. I'm going to actually do this in place, right? Yes, no boundary checks, not for now. Like I said, we're just going to bash through some stuff. But at this point, the assumption will be that if this constructor is called, then we have a full set of data in order to pull the thing apart. But we will get to boundary checking this once we've actually got a version of this code running and running successfully. Bearing in mind, I know we're already half an hour in, and we're nowhere near as close to what it is that I want to do as expected. So anyway, all right, so let's go exor bytes. We're going to take in the exor key. We're not going to specify the length because we're just going to assume that whatever array we've been given, that's how the whole thing is the key. So given that we're actually going to do the exoring in line, I'm going to take a reference to a byte array, and we'll call that target. All right. And then what we want to do is we want to go for an iterator of some kind. We'll start at 0. We'll make sure that I goes up to whatever the target length is, and we'll increment I. So we're going to go over the whole array, and I'm just going to go target whatever index we're in. We're going to XOR directly with the XOR key that matches I, and we're going to mod it XOR key.length. So basically this means that this XOR key will be like looping over itself as things go, and we'll just be overriding the original. So from here we should pretty much be able to go XOR bytes, give it the XOR key, and give it the data. Oh, actually we need to give it ref data, don't we? Yeah, does that make sense? Yes, ++I, not I++. Correct, Mongo. That's a habit that I formed a long time ago. Does anyone know why you do I instead of I++? Mongo, you're not allowed to answer. I love this song. This is part of the Rocket League soundtrack. Great tune. You increment before use, yes, but if you increment after use, then behind the scenes you have to keep track of the previous value, so you have multiple things going on instead of just the one. So technically I++ is slightly less efficient than ++I in this situation. Okay, so we've exorted the bytes. From there, what do we want to be able to do? We want to be able to basically parse that stream of bytes now, right? Into the packet. So let's create a separate. Let's go private void parse data. Create a byte array data. We might even make this by ref as well, so that we don't make an unnecessary copy. So ASP.NET Core. No, this is just plain .NET Framework stuff, my friend. I'm a bee. Hello, Gonathu. Greetings. Thank you for joining in. So what I'm going to do here, this is slightly different to what we're doing before, but in some ways it's kind of similar. So first of all, we need to take that array and shove it in a stream because we're going to use the binary reader, right? So let's go using var memstream. Oh, actually, I'll just call it stream. Stream equals new memory stream. Can't type. System.io.memory stream, and we'll give it the data. Then we're going to go using var reader equals new binary reader and give that the stream. Okay, so in here we now have the ability to read information straight out of the TLVs, right? Now, here's something really important. Let's go back to our Fedora install. Oh shit, did I just somehow start? Should get rid of that. I never want to start that. Let's go back over here because I want to see the body of this. Now you'll notice if we look at packet header size, you'll notice that the full size of a packet header includes size of the exhort key, size of a session GUID, size of the encryption flags, and then you've got things that are specific to the packet. So then there's the size and the type. Okay? So what we need is 4, 16, and 4. That's 4, 16, and 4 before we get to the length, okay, of the packet, and then followed by the type. All right. So that's 4, 16, and 4. That's 20 bytes that we effectively skip. We know what the size happens to be. Or I should say, at this point, we actually don't care what the size is. We just know that we've got everything that we've been given. And so I'm going to abuse this knowledge just a little bit, right? So what am I doing? I'm going to go reader dot. Can I go seek? No, I can't. I'm going to go basestream.seek. So I'm going to move the pointer. And I'm going to jump to... How far do I need to go? What was it again? 4, 16, and 4 and length. So we've got 16 and 16 and 12 is 28. So let's skip 28 bytes for now from the start of the stream. So we're effectively just jumping right over the start of the header because we don't really give a shit. At this point, we know we've exhorted everything. And then from here, we want to start... Oh, actually, we want to read the type, don't we? So we need to go this.type equals reader.read uint32. Now, I did some reading of the documentation earlier today. And it turns out that read uint32 from a binary reader does not in any way take care of some things that we need to care about. So, we're going to fix that. Public static class binary reader extensions. Okay, I'm going to create a new class called binary reader extensions, and I'm going to move that to a different file. That's the lazy way of doing it. Okay. Now what I want to do is there's a few things that we need to cater for here, and we need to make sure that we are reading the data in the right way. All right. So we're going to go public static. We're going to be returning a uint32, right? And I'm going to call this read dword. So this is a dword in the context of Meterpreter, right? Binary reader. So for those of you who don't know, this is how you set up extension methods. Okay? So when we read a dword, what we actually want to do is we want to go reader.read uint32, which is fine. The problem we've got is that we need to reverse the bytes, okay? So there's a IP address thing class inside system.net, and there's a network to host order function, which pivots the bytes around, okay? But you'll see it either takes an integer, a long, or a short. So we need to take whatever this is, shove it in here, cast it to an int. Oops. Yep. And then return whatever the result of that is, casted to a uint32. So, man, this is bringing back some wonderful memories, hey? So that means that we can actually get a 4-byte int with the stuff flicked around. Now that doesn't help us specifically in this case because we're returning an integer. But instead what I actually want to return is a packet type. So I'm going to do a read packet type extension. And I'm going to do exactly the same thing, right? But the difference here is I'm just going to go return packet type casted reader.read dword. So all I'm doing is making a little helper function that says, at least in the code, I'm going to read packet type. Oops. So there you go. And now that should compile. Fingers crossed. Memories or nightmares? That's a great question. I'm going to go with memories. All right, so we have now the ability. So what I need to do is call this thing, don't I? Parse data. Give it the data. All right, so now we have the ability to at least read the type, okay? Which is handy, but is only going to get us so far. So from here, we need to then go, right, we've got the rest of the packet to pull apart. Let's pull that apart, okay? So we want to loop over the reader. We want to keep reading until all of the TLVs are done. So let's go while not reader dot... there is no finish. There's that friggin' peak thing again. So let's go reader is finished. And we'll go back over here. Public static bool is finished. This binary reader. And then we're going to return reader.peakchar doesn't equals -1. So if it's finished, then that'll return -1. And now this should be okay. So while it's not finished, why Windows sudo ghost? If you have a little bit of a look at the history, mate, we're actually building something specifically targeting Windows. So that's why Windows. I make mostly JS apps. JS is a versatile language. I hate JavaScript. I'm sorry. I make no bones about saying it. JavaScript is an abomination, and the fact that the internet runs on it is just absolutely astounding to me. So, yeah, no worries, Pseudo Ghost. Thanks for joining in, man. Appreciate it. What we're doing is we're building another implementation of something called Meterpreter, which is a RAT associated with Metasploit, and we're just building a new version that runs on the CLR. So there you go. It's good to see you guys trolling it as much as me. All right. Okay. Oh, you know Metasploit well. Excellent. Sorry. Okay, where do we get to? We want now. Oh, that's right. So we now want to be able to go. We want to create a new TLV equals new TLV, and I'm going to give it the reader. All right. So this basically means, hey, I want to create a new TLV packet, and I want the TLV to read itself from the current state of the reader. All right. So let's duck into here. Now, what do you think web applications should be written in? Depends on the web app, my friend. I don't have a catch-all answer to that. It's like saying, what do you think we should construct this house out of? Depends on where it is, depends on whether it's a high wind area, whether the soil's volatile, whether it's on a slope. There's too many answers to that question. So the answer is, and should always be, it depends. What is the problem that we're trying to solve? That's my relatively purist view of such a thing. Yeah, client side, we're definitely stuck with JS. Had a couple more follows. Abishkish, sorry if I said that wrong. Cletus Van Dam, Van Dam, Pseudo Ghost, and Slanjo. Thank you all for the follows. You're all wonderful human beings. All right, so now that we're back in TLV land, we're gonna do some TLV specific stuff. All right. Now, my stance that we had before is going to change just a little bit, right? A TLV can be one of two things. A TLV can have its own type and value, or it can have its own type and sub-TLVs. Sod off with the logic and reason. Can't help it, my friend. Can't help it. So what I'm going to do is I'm going to have a private object, which is the TLV value. Okay? We'll start it off as null. Okay, that's going to be a hidden value behind the scenes, and this value is only going to be set if the TLV is not of type group, if it's not a container for other things. But what we do need, like, see how our packet contains a dictionary of TLVs. Well, a TLV can actually have a sublist of TLVs. So I'm going to do the same thing here. So we're going to have a packet which we know has a dictionary of TLVs, and every TLV that's a group can also have its sublist of TLVs. Okay, does that make sense? And so with that in place, we've also, it's going to have its own type. So we'll have a TLV type, which is a get. We should be able to set these publicly too. I'll leave it as public for now anyway. Righto. So let's take the same approach that we took with the constructor. TLV is equals new. So behind the scenes, depending on the way that we create the TLV, this will always get constructed because we want to force the user to set certain things in certain contexts, right? So we're going to give a binary reader to the TLV. Nope. Reader. System.io binary reader. Use the default constructor behind the scenes. Now here's where it's going to start getting a little bit of fun. Now remember, once we've got to the point where we have a TLV packet to be parsed, we want to read the length and then the type before we do anything else. Okay? So what do we want to do? Var length equals reader.read dword. Beautiful. We can actually read the dword. But remember, the length contains whatever the full length of the TLV packet. That includes the 4 bytes for the length and the 4 bytes for the type. So the actual length of the data that we want is whatever that value is minus 8. Does that make sense? Remember, we've got length, type, data. Okay? And that is 4 bytes, and n bytes. And remember that n equals length minus 8. So we're interested in the length of the data. Okay? So we should be able to then go, pardon me, this dot type equals reader.read. We're going to do the same thing. Read. See, we've got the read d word, but we actually want to cast that. So I'm going to call that read TLV type. And I'm just going to do a blatant copy and paste. Packet. CFT. Oh man, that highlight's horrendous. We're going to have to get rid of that. Okay, so we should be able to read a TLV type and return a TLV type. Okay, so that's cool. Let's get rid of that. Okay, then we actually want to do things slightly differently, right? How do I make my Fedora look like yours? Maybe one day I should sit down and talk about how I do this. So right now I'm flicking between VMs. This is Windows and this is Fedora. But what I want to do now is, like, we need to keep track of something. This is something I thought about in my sleep, strangely enough. What I want to do is I want to separate packet type from TLV type, and I also want to separate the base types into their own thing so that we can handle things a little bit differently. All right, so we did actually briefly discuss this, but yeah, I kind of renege on my stance. So let's do another enumeration. Public in enum. I'm going to call this the meta type because that's what it's called in the Metasploit source code anyway, right? Now there are thankfully a small set. There's one called none, which I haven't seen used, but for the sake of being completely thorough, we're going to leave that there. Now string equals 1. We have this from before. Again, I've got my referencing over to the side. It's not on screen, given that I'm typing it out. So that's what a string is. And then we have a uint, which is 17, right? Now the other ones I've got here are 18, 19, 20. So what I should do is this. If I go QQ, I can go YYP Have I got caps lock on? F to here, Control A, Q, and then I can at Q. Isn't that wonderful? But obviously I want to get rid of the uints. Oh, it's ghastly. So that's raw, bool, Q word, and then there's some other ones. I think I got caps or something stuck on. No, I don't. Let's see what happens now. Keyword compressed is actually 29. Right? Q. No. It's bizarre. It's behaving slightly differently to what I would expect. So that's 30, and then finally complex equals 31. So they're the main types. So I've got to change this. This is driving me nuts. Sorry, wrong thing. Let's go tools, options. Where is it? It's fonts and colors, isn't it? Fonts and colors. Wait for the VM to spin. Right, in the text editor, we're going to look for... There's got to be a VIMU thing in here somewhere. Here we go. Highlights. Oh, there we go. Let's change this background to something a little more digestible. I want to make it dark enough, but also light enough. Maybe something kind of tealy. Let's try that. Is that also the same? Yeah, let's reuse that. HL, incremental search, visual range. Ah, there we go. Okay, so we can actually read stuff now. That was horrible, hey? Okay, so we got none, string, uint, raw, bool, compressed, group, and complex. So string is obviously a string. Unsigned integer. Raw basically just means a block of bytes. Bool is a boolean. Keyword is a 64-bit integer. Compressed means that it's actually gzip compressed, which we may never handle. A group is where we have nested ones. And to this day, I still don't know what complex is. Now, what I want to be able to do on the fly is to be able to extract the meta type from a TLV type, right? So, what I want is to be able to create a mask of all the meta types. And so I'm just going to do this. None or string or uint or raw or bool or keyword or compressed, or group or complex. Alright? So that means we can go metatype.all and then we can mask. We can mask it out and get the one that's actually meaningful to us. Okay? Now, we need to fill in what the TLV types are, which is a long and verbose process for every single TLV type. So while I was pondering this a little bit earlier on, I thought, I know that this is one of the things that I'm going to end up having to type out on stream, and it's going to bore people to death. So what I did was I typed out just these TLV types as they currently stand, just with a focus on the core. So I haven't done all the standard API ones, I haven't done any of those. But this is the one thing that I hope you'll be grateful for me doing without you, because typing all of these out would probably have driven you nuts. Right? So I said we're going to do all of this stuff together on stream. This is the one thing that I didn't do on stream. So hate me if you like, but I think we've done us all a favor. Does that make sense? I'm sorry if that's upsetting, but I couldn't have done that on stream. It would have been seriously boring stuff. So, now, what I'd like to be able to do is I want to be able to take a TLV type and get its meta type. Hey Goobster, thanks for coming, man. This is before decryption of the data, right? Reading the TLV type is right after getting the packet. So there are two scenarios. We're going to pull the packet header apart, and then when we have detected that something's encrypted, we will decrypt it. And then once it's decrypted, we will then pass it into this TLV parser. Okay? We are at the moment focusing only on packets that haven't been encrypted. Okay? Just so that we can demonstrate we have the ability to pull TLVs apart. And then from there, we will add encryption on top. Okay? So what I also want to be able to do is convert from a TLV type into its meta type. Okay? So because, again, I want to make the code look relatively tidy, we're going to have another extension class. So public static class enum extensions. I like doing it this way because I can get all of the Viz Studio refactoring functionality to create the files for me. See how there's this enum extensions now? So I didn't actually have to do anything for that. Public static. Now we're going to get a meta TLV type from a TLV type. Okay. Now, in order to do this, public static, I've got to go, let's say to meta type. Meta type, I've got to give it a name, to meta type. That's what we'll call it. Now, first of all, we want to take a meta type.all, so the full mask of all of the meta types. We need to cast that to a TLV type so that it's the same type. And then we're going to mask that with the TLV type itself. So that will give us one of these. Where is it? TLVs. It'll give us one of these values as a TLV type, right? But we want to return a meta type. So we'll take that value and cast that back to a meta type and return it. Oops. Okay. Because then, at this end, beyond the TLVs, we can basically from there reference the actual meta type of the TLV type quite easily. Does that make sense? Any questions about that? Hopefully that makes a little bit more sense. There shouldn't be anything particularly mind-blowing about this. Now, this is where we need to start catering for individual cases. So, now bearing in mind that meta types, which come up here, I'm just going to wind this back. Meta types are all of these, so strings, uints, raws, bools, all that sort of stuff. We actually want to start pulling data apart. But the one that we need to cater for at the moment that could be subtypes are groups. Okay, so inside here, when we're pulling this stuff apart, pardon me, if the meta type is a meta type of, group, we want to handle something a little bit differently. Otherwise, we should be able to just do a fairly simple check, right? So let's, okay, so what we're saying here is handle the processing of sub TLVs in the case of a group TLV. And I guess otherwise, handle each value on its merit. So this is basically me saying this current TLV is going to be of this value type. Okay, so let's do a quick switch and we're going to have a look at what the meta type actually is. Ooh, we've got another follower. Who is that? We've got a couple. Slando, Maggot Eater of Doom. What an awesome name. Thank you, Maggot Eater of Doom. Okay, so the cases that we're looking to cover for here, actually what we'll do is, for now, default, go break, we're going to say throw new invalid argument exception. No, not invalid, just argument exception. And here we'll go string.format and we'll give it a message. So we're going to say unexpected meta type And we'll give it whatever the meta type is. So that'll at least let us know. We don't need a break statement there. So if we manage to get all the way down the bottom there, then we should buff. Thanks. Spend all 2 minutes coming up with it. Do we know you by another name, Maggot Eater of Doom? All right, so let's go with, we'll start with bull. So if we get a bull, what do we want to do? First time here. Well, welcome. Thanks for coming along. This dot value is going to be reader.read bool. Now, read boolean, according to the documentation, let's actually check, because I'm pretty sure that it does it on a per byte basis. Now, behind the scenes, that's exactly what Meterpreter does. So if binary reader read boolean, let's see what it does. True if the byte is non-zero, otherwise false. Excellent. That's exactly what we want. So read boolean. So that's going to return boolean, and that's basically all we need to do. Case metatype dot. So complex and compressed. For now I'm going to go throw new not implemented exception. We'll go string.format. Meta type. Don't know why I can type so badly. Sorry, don't support whatever that is yet. We should also put this in, if that makes sense. Is everyone still with me? Everyone's very quiet. Makes me think I'm doing something wrong. Okay, so case metatype dot. Okay, so we've got bool complex compressed group. We know we can't get here because group is the case above. We're gonna leave. See, I might even put none in with that stuff. Case metatype dot keyword. This dot value equals reader dot read. So we've got read D word. We actually need a keyword. So let's go back to our, our extensions. It's quiet because it's interesting and mind twisting. Fantastic. That's what we want to hear. Just absorbing a lot. That's what we like to hear, people. Okay, let's go back to our binary reader extensions. And we're going to do exactly the same with keyword, as D word. Here instead, though, we are reading a 64-bit int, and we need to cast that back to a long, because that's what the overload is expecting. And then we'll return that as a 64-bit. There we go. So now we have a keyword. So that should be that done. Case, meta type, we got them all. Raw, okay, raw's super easy, right? This dot value equals reader dot read bytes. Now, however long we were told to read. Length. Length is currently an unsigned integer and it's expecting an integer. So we'll just do a straight cast. We're not going to end up in cases where we're copying like more than 4 gig in a single packet. So we don't actually have to worry about overflowing or anything like that. Does the internet address reorder tricks support? Yes, it does. Yes, it does. So you see network to host order has multiple overloads parity. You see one here says int, one's long, and one's short. So int is 4 bytes, long is 8 bytes, and short is 2 bytes. So that's why I'm doing the cast here, to make sure that the right one is invoked, and then we cast it back to what we were expecting type-wise. Does that make sense? Does that answer your cue? Raw's super easy. Case meta type dot, what have we got left? String. Okay, so I would assume that what we're going to have to do is we've got reader.read bytes. We've got to read the length based on the string, but we need to do the text encoding thing, don't we? So encoding, systematic text encoding, we're going to use UTF-8 dot get string from those bytes. this dot value equals break. And then I think we only had one left, didn't we? Metatype dot uint. Easy. This dot value equals reader dot read dword and break. Okay, so they're all the main sort of meta types that we're at least going to support for now. But the one thing we need to do here is cater for groups, right? Now this is where we're going to start adding to this because we're going to have multiple values, all right? Actually, let's cover that in just a minute. What I'd like to do before we go ahead and handle all of those cases is let's expose the ability to read the values. So let's say we want public string value as string. Okay. Now we want to expose the ability for people to get values out based on the type, because remember, we actually have this base. We're boxing. We're cheating. We're using boxing. In .NET, boxing means converting an object. An object of a strong type to the base level type, the type that anything can be casted to, and that is an object. So boxing means converting it to an object. Unboxing means taking it out of the object box and putting it back into a strong type. So here you can see we are boxing the value by taking a strong type and storing it in an object. Now we're going to do the opposite based on how people want to talk to it. So we do have to make some assumptions, but what we should probably do, so what we do here, for example, is go return string. We've got to do casting this dot value. Now the problem is that we want to make sure that we don't get like some crappy runtime error. Instead, what I want to do is we want to validate that the type actually matches, that we should, right? So let's do this. We'll have a private void validate type, and we're going to ask for the type that you want to validate. Okay. Now, the reason why I'm doing this is we're going to make this generic based on whatever it is that we've given. Now, in order to do this, we need to go, right, we've got the type that we're expecting, so that's T. So expected type is type of T. Okay, so that's the type. The actual type that we have is this dot value dot get type. Bear in mind that this dot value dot get type will throw an exception at this point. So what we should probably do before we do any of this is go, if this dot value is null, then we should go throw new, we'll call it an invalid operation exception, string.format. So what this actually means is that the TLV doesn't have a value, which implies it should have sub TLVs. So the message we kind of want to give is, say, you're trying to extract a value from a group TLV. That's basically what that means, right? Invalid operation exception, unable to extract value from a TLV of type TLV type dot Metatype. Metatype dot group. That's basically what that means. Okay, so here we can assert that the value isn't null. Okay, so then what we need to be able to do is go, if the expected type is not the actual type that we have, then we've effectively got an invalid cast, so to speak. Is this another invalid operation exception? It probably is. So let's take a copy of that. We'll throw another one and we'll say given type, expected type blah does not match requested type blah. Okay, so that means we would have expected type, actual type. Does that make sense? I think T is already a type, so type of T. Incorrect. T is a declaration of a type at compile time. Type of T is an instance of a type at runtime. Mongo? Does that make sense? That's compile time. That's runtime. Yeah, cool. Good question, no? Good question. So what I want to do now is go validate type string. We just want to say, is this a string? Now, if it is a string, then we won't throw any exceptions and everything will be fine. And we'll be able to do the cast, knowing that we shouldn't even get an invalid cast exception. Okay? So from here, we should be able to go public bool value as bool, for example. Validate type bool, return bool, unboxing. This is the unboxing process. Yeah? So let's do this a little bit quicker. And validate as value as uint, so uint 32. Oops. Int 32. Oops. Can't type. It's not uint, is it? We don't want uint. We want dword. Let's use the right nomenclature. Uint 32. Let's get rid of that and recopy. We want keyword, so that'll be 64. 64. 64. It's up to the caller to know they request the correct value. Yes, it kind of is. And when you think about it, when you're pulling TLVs apart, you kind of should know what that is anyway. So if I'm handling a packet that says I want to get a directory listing, then if I extract a TLV value, which is identified by the word like TLV type directory, so I'm saying give me the TLV type that is of type directory, it's kind of implied that that's a string. So I should be able to go get that value as a string. And, you know, we've got to, because we are the consumer of our own API here, we should pretty much be sure of the fact that that's going to come out as a string. We are defining that. So, yeah, there is a risk that it'll break. But this is exactly how all the other Meterpreters work behind the scenes as well. There's this assumption that if we get a packet that says the type is a string and that it matches exactly the same type as TLV type directory, for example, then that is going to be of a type string. So this is really just defensive, so that if for some reason packets get corrupted, we can still sort of trace back exactly what it is that's going wrong. I hope that's helpful anyway. What have we missed? We need a byte array, so value as raw. So that's a byte array. What else are we missing? What have I missed? We've got dword, keyword, bool, string, raw. For now, that's it, isn't it? We're not dealing with these ones just yet. I can't even remember what they are, so we'll have to dive into that at some point. Let's see if we can build that. We are an hour and 15 minutes in, man. I was expecting us to go a little bit faster. If I'm going too slow, please let me know. I'm trying my best to sort of go at a reasonable speed so that we get something done. But I'm still going a little bit slower than I may otherwise, because I don't want to gloss over stuff. So sing out if I'm going too slow. I will try and speed things up. Now, remember, we're going to be able to create TLV responses, right? Hey, Slickus, welcome, sir. Thank you. Thanks, Maggot. That's useful, mate. I want to be able to create a packet and then add TLVs to it. I want to be able to create TLVs and add TLVs to those. So ultimately, what I want to be able to do is go public void add and give it a TLV to add to the current whatever it happens to be. So this is effectively all we need to do. We just need to be able to go if the TLV, hang on a second, if this dot TLVs, if the sub TLVs has already exists, So TLV.type. So if we already have a list of TLVs of that type, then this .TLVs, TLV, actually, you know what? I can probably do this a little bit differently. Let's do this. var TLVs equals default of list TLV, right? And then if this .TLVs .try get value of TLV .type TLVs. What am I doing wrong here? What is the error? This.TLVs try get value. I don't understand what the problem is. Argument must be, oh, with the out. Okay, so yeah, it's the same as ref, right? Okay, so what this means is, like, if we call try get value, it's going to return true if a dictionary element of this type is extracted. At which point we should be able to go TLVs.add, because everything's by reference at this point. TLVs.add TLV, the TLV that has been passed in. But if it doesn't already exist, then we want to go TLV, hang on, where are we? This.TLV. So we want to add a new element, .add new list of TLV, and give it the TLV that we came in with. So that's a special list initialization feature. And we need to give it TLV.type. So we're adding a new dictionary element for that type, and we're giving it a new list which contains the one value, which is the TLV that we've given it. Does that make sense? So that means when we're dealing with subgroups, so if we're dealing with a group meta type, we effectively want to simulate everything that we have already done, if that makes sense. Maybe it doesn't make sense. So what I'm going to do is I'm going to recursively call myself while creating new TLVs, but I can't make use of the same, well, I could make use of the same reader, but I'm not going to. I'm going to create a new reader. So for example, reader.read bytes. Bear in mind that the length is still accurate here. So int length, that's how many bytes we want to get out. So that's how many bytes we need to read, which will encompass all of the TLVs in that group. Okay. So let's wrap that in a new memory stream. Okay, using var stream equals new memory stream. Now we're going to create a new reader. So let's call that group reader equals new binary reader, and we'll give it the stream. Now we've got our own little pocket of stuff. We should be able to do exactly the same thing as we did in the packet reader, right? Which is this. Okay, so while group reader is not finished, let's add a new TLV reader. So here we're going like create a new reader, create a new TLV based on the reader, and we're going to keep looping and adding TLVs to our dictionary until that reader is finished. And because we've got appropriate using statements in place, everything should be cleaned up nicely for us. Right? Does that make sense? Right, so the good thing about writing this is that this functionality here should work exactly the same for a packet. Right? I know it's a slight bit of code duplication, but that's the name of the game. It's not a lot of code duplication, but what that does mean is that when we're parsing the data, we should be able to pretty much do exactly the same thing here, right? Add new TLV reader. This keeps building first time. I'm getting concerned. This isn't going to work first time, just so you know. All right, so here's what we want to do. This actually builds. So let's set this as the startup project. Definitely builds. All right, so what I'm going to do is we're going to go through the process to make sure that this stuff actually behaves. So we haven't actually stepped through any of this stuff to make sure that it works, and I haven't put any unit tests around it, but you know, it is what it is. So we're going to run, we're actually going to debug this stuff. Is everyone able to see this stuff fairly clearly? I hope so. So actually we should change to debug mode so that our breakpoints will actually hit. Thank you guys. In before you built an empty project. All right, so hopefully what I've explained so far is actually useful. All right, debug and run. Okay, so we'll create a new packet. Step in. So as we can see, we step in here and it creates a dictionary of TLV types to list of TLVs. And then we're going to extract the 4-byte XOR key. Now, if we have a look at data here, we should see the first 4 bytes. Oh, this is really small. Can I increase the font size? I don't know whether I can increase the font size here or not. But we've got our 4 bytes are 39, 96, 78, and 30. And then after this call, we should have those 4 bytes. There you go, 39, 90, 78, 30. Okay, that's good. That's a no-brainer. Let's just see what happens here. Now, remember, for this packet, it's the very first packet that's going across the wire, which means we've got a 4-byte XOR key, we've got a 16-byte session GUID, and we've got a request header. So those first 20 bytes are all 0. And what that means is that we should see a loop in this target. So 39967830, 39967830, 39967830, 39967830, 39967830, 39967830. See what has so many. Here we go. That byte there, byte number 27, is the first one that's going to change. So when we're going through the process of XORing this, everything's going to come out with 0. Didn't you mention last stream there was something in the TLV packet structure that stopped the same structure being repeated as if it was all nulls, or does that come later? Currently, yes, that's right. Thank you, Peleus. Peleus is correct. We have a repeating XOR key, so it's obvious that there's a pattern in here. What I do plan on building is something where the XOR key effectively operates as a seed for a custom byte random generator, which we can then use. Yes, that's exactly why you don't use a repeating XOR key. Thank you. But we currently do, so we have to deal with it until I've got to the point where we can use that value as a seed to generate streams of bytes. Okay. Righto. So let's step through this a few times, and we should see this all changing to zeros. There you go. Look at it go. 0, 0, 0, 0. More zeros, more zeros. Where's that 61? See, they're all zeros. So this is the, like I said, the 4 bytes for the XOR key get zeroed out. 16 bytes for the session GUID. Another 4 bytes for the request type. And now we're into the next, there you go, 2, 35, 0. Okay, so let's step out and let's see what that data looks like. Lots of zeros, 235, 38, 1, 1. There you go. So we've got some non-standard bytes in there at least. Okay. All right. Moment of truth. Let's see if this actually does something useful. So we're going to parse the data. Open up a stream and a reader. So we've seen what this is before, so we know what the story is. Now, we'll do some checks here. So base stream.seek 28 seek origin begin. So we're saying from the beginning of the stream, we want to seek to the 28th byte. Okay, so if we looked at the data, which is what it's wrapped in, the 28th byte gets us to the length, right? Is that what we want? Let's have a look. Where are we? Let's go to the reader. So the reader base stream position is 28. And then in non-public members, we should have a buffer. There we go. Now that's come to here. So the question is... Oh yeah, that's right. So there's length and then type. And the type is a request packet. So we've skipped the length, which is it's whatever that would be in hex with 4 bytes. So 0, 0, 2 and 35 are the 4 bytes. 1, 2, 3, 4. So that should come out as 0, which is a request packet, right? So this dot type should be, it should be 0, but clearly it's not. Why is that? Read packet type. We've got another follower, whoever that is. Saba9, thank you for the follow, mate. So that didn't come out as expected. Read TLV type, read dword. Things never work first go, do they, hey? Let's just quickly revalidate our steps. 45 days, 54 users, load average. You want to know how long we've been streaming for? Almost an hour and a half. Almost an hour and a half. So what I'm going to do, let's go to here. And we'll just make sure that we're not doing anything particularly stupid. I don't think we are. But yeah, that should be okay. Alright, let's debug. Let's see what happens. So actually what I might quickly do is just put a comment in here. Skip the first 28 bytes, which contains exhort key, session GUID, which is 16, length, is that right? Length 4. Oh, is that our problem? So that's 24, and we're jumping over that to get to the type. Oh yeah, so exhort key session. Oh, this is what I'm missing. Sorry, encryption flags, which is 4 bytes as well. That's right. Okay, so we skip exhort key, session GUID, encryption flags, and length. So 4, 16, 4, 4. So that's definitely 28. So at that point there, we should be pointing directly to the type of the packet, which is a meta type, right? So we'll read this packet type. Now, let's just make sure that we're doing the right thing. Let's go to this immediate window, and we're going to go reader.read uint32. So that did come out as 0. Okay, so that makes sense. Packet type. And we know that the packet types are, like, request should be 0. Okay, so that's fine. And this dot type equals 38. Does that make any sense? Doesn't, does it? This type equals 38. Why would that be the case? Is it because, maybe we're doing something wrong with our network to host order? So you think that might be it? Yeah, I think it. Am I missing something here? Can you guys see anything wrong with what I'm doing there? Let's get rid of those breakpoints again. And this time I'm going to set the breakpoint to here. 32, 33, 32. Anyone? Okay, so now that's interesting. Stop. Rerun. Why are we seeing that inconsistently? Okay, so that's definitely 0. So if we went IP address, network to host order, 0, we get 0. And that's exactly what we're returning, right? So if we uint32 this, we should still get 0. If we cast that to an int, we still get 0. I wonder if this is a debugging quirk. But you can see like that's actually come out as a request like it should. Well, what do you know? I think it's the debugger. Yeah, I think it is too. Okay, so is it finished? So it shouldn't be finished. So we're going to go and add a new TLV. So same story, we're going to create a dictionary. Now we're going to read the length, which is 30 bytes. The type is a method. Okay, so the method is the thing that contains what should be a string. And that'll be things like, if we go back to our VM for a minute, this first packet here is the one that says I want to negotiate packet encryption. So we should see, I think it's core negotiate TLV encryption or something along those lines. So let's see what the meta type comes out at. It comes out as string, so that's good. If it's a group, we're going to skip, switch meta type. Moment of truth, is this going to pull a string out for us? The value is core negotiate TLV encryption. Ooh, look. Can you see that? It's got a null byte at the end. And that makes sense actually because the length actually includes the null byte at the end. Okay, so now this is important. We can't go read bytes and read length -1 because we still need to read the null byte. But what we're going to do instead, let's get rid of the null byte at the end. Because when we're doing string comparisons, we want to make sure that that's completely gone, right? All right, so this .value, there you go, core TLV encryption. That's without the null byte, so that's cool. Okay, now when we add, we try and get the, okay, so this is just a declaration of a variable. So we've got a null list. And when we call this, we obviously don't have anything in our TLVs because the dictionary is empty. So we'll create and add a new one. So here we can see we've got a TLV in here that is of type method and with a core negotiate TLV encryption in it. Okay, that's cool. Let's see if this works. What do we got this time? We have a 33 byte request ID of type string. So we know strings, well, we kind of assume strings are working. So there you go, there's the request ID. Now remember, when we receive a request from Metasploit, the response needs to contain the same request ID. Okay, so that basically means that once we create a response packet, we need to take the request ID and map that into the response packet so that Metasploit can correlate the two at the other end. Okay, so that's what the request ID is. So pretty much every packet that comes in that's a request should have a request ID and a method. Now what else we got? Length, All right, so now we have a 452 byte RSA public key. Let's see what this .value has. There you go. Looks like an RSA public key to me, with new lines and everything. Okay, let's see how we go now. Is it finished? Okay, it's finished. So that means our packet should have 3 TLVs in it. There you go. Method, request ID, and RSA pub key. Each one of which has one. That's pretty cool, hey? So if we were to consume this, we might just go like system.console.writeLine. The packet type is, let's use a little bit of linkiness here. We'll go packet dot TLVs. TLV type dot sorry, no, what is it? Type. So this is a method. We want the method, don't we? The pack there, we'll just say the method is. Now remember, this is a list, so we're going to get the first, and we're going to get the first element out of the list because we know there's only one at this point. And we're going to get the value as a string because we know it's a string. The method is that, the request ID is that, and because we know for now the RS that will go, the public key is RSA pub key. So if we run that, there it is. Method is core negotiate TLV. The request ID is that. Public key is all of that. Yeehaw! We can parse some stuff. Now that's only one example, right? So we should probably look at bringing in some other examples. So we might do a sort of generic packet dumping thing. Why does the TLV stuff here have all the commands as strings? Because that's how they were originally implemented, mate. That's how they were originally implemented. It's pretty rough, isn't it? So, what I'm going to do now is I'm going to cheat. We're going to do this. Packet.string. And we're going to override to string. So, in order to do this properly, we are going to go, this is going to be pretty filthy, but it'll do the job, right? We're going to go for each var k in this.tlvs.keys. So for every key in the dictionary, we're going to go for each var TLV in this.tlvs. Okay, so for every key we're going to iterate through the TLVs in it, and we're going to do var writer equals new string. What is it called again? Is it string? Not string writer. Yeah, you can, but I don't want to do that. You can iterate. Oh, actually, I think if you go for each bar x in this.tlvs, let's see what this does. Oh, there you go, x.key and value. Yeah, so we can do that. We'll call that T. I don't know why I did that. It must be force of habit from God knows how many years ago. I think it might be an ordering thing too. But yeah. So what do we want to do? I actually want to generate like a string buffer. So I can't remember what it is, because you shouldn't append strings together with plus equals because that's terrible. So was it new? What is it called? Does anyone tell me? Can anyone tell me what it is? It's been such a long time. C#, append a string in the loop. Oh, as soon as I see it, I'm going to kick myself. Where are we? String builder. String builder. That's what it is. System.text.string builder. So s.append format. We're going to say key TLV type is that, and new line, and then we'll go value is whatever that is, followed by 2 new lines. Now it's gonna be ugly when we print it out, but now there's multiple values, right? So we want to go TLV type with a new line, t.key, and then for each, I'm going to go back to k for that because it's effectively the k. For each var TLV in k dot value, because we know that's a list. s.append format. Now here I'm going to go TLV.toString, and we're going to override to string elsewhere. Return. We probably don't even need to do that at this level, do we? Because the TLV type can go elsewhere. What I'll do instead is go packet type. And we'll go this dot type so that we can spit the packet type out. And then for each one of those things, we will go s.toString. So we need to do a toString for the TLV itself, right? So let's go down here just before the privates, and we'll go override to string. Man, I've got 15 minutes to go. Can you believe how fast this is going? Yeah, string builder is a class that allows you to just append lots of strings in memory, and it's way faster than just doing plus equals and whatnot. It's way more memory efficient. So I'm going to do the same thing here, right? We're going to have, oops. And actually we should do the same thing. s.append format, TLV type, this dot type. Okay. And then, put that in, keep the compiler happy. And then for each var value in if this dot type dot get to Metatype equals Metatype dot group. So we know we've got to go recursive. We can technically have multiple groups, so we should do that in a loop. For each... No, that's not what we do. We do it this way around. Okay. Ugh, come on, Visual Studio, do better than that. For each value in this .tlvs. s.append format tlv.toString. Sorry, value.toString. So there you go, that does the recursive bit. And And then we will go s dot append line. Else we need to dump the value out. We can be cheeky here. I guess what we want to do is make sure that we don't dump out anything that's like if it's a raw set of bytes. But for now what I'm going to do is just like to string it. We'll see what happens. S.append format, whatever it is that we've been given, followed by a new line, this.value.toString. Packet type request, TLV type method, core TLV encryption, request ID is that, RSA pub key is that. Okay, so if we've got the ability to dump that out, then let's go back to our program. We want to create a bunch of byte arrays. So let's go equals new list of byte arrays. And I should be able to initialize it like that. Can I do that? New byte. There we go. So there's one. Right, now we should be able to go back to here, pull out a couple more. Let's see what these do. Oh, that's standard API right there. I might skip that one because it's huge. Let's take this one and go new byte array. Getting close to end of time, but it's got to be. And we'll do one more new byte array, just for the sake of validating what it is that we've done. Let's just grab one more out of here. Do near the bottom. Let's grab this one. Oops. Groovy tune. Now, for each var data in, no, we'll go D in data. So for each one of those byte arrays, let's dump it to screen. What do we got here? Random C#, string builder. We need a 24-hour string. Hey, look, I would consider doing something like that, but it would come with some conditions, and those conditions would mean that people who are watching pitch into a charity. Oh, there you go, marathon charity stream, like Russ had just said. If you threw money at a charity, I would do something like that. Okay, here we go. Let's see what it did. Packet type request. We know that one works. Packet type request method core machine ID, request ID. Request type method standard API config get interfaces. So it looks like it's actually working as expected, which is pretty exciting. If you threw money at a charity, AJ, we might watch you for such a prick. All right, so fair to say at this point that we've actually got the ability to parse TLVs into a packet with the provisos that we don't currently support encryption and that we're able to read the entire chunk off the wire in one go and pass that to a packet. I would say in the next... Actually, no, not in the next stream. I was going to say in the next stream, maybe we'll look at supporting reading bytes off a stream and see how that would work, but I think we'll worry about that another time. My plan at this point was to go and make it so that the .NET 4 one builds, but we don't really need to. So right now, because we've only got 10 minutes to go, it's probably worth sort of just finalizing questions and thoughts and skipping until Friday. So what do you guys think? Wolf goes Naya. You're confused. Join the club. We are currently building a TLV packet parser in .NET. And if you'd like to understand what that means, if you have a look at the history of the streams and go to vimeo.com/ojreeves, you'll see a history of streams where we're building this application and going through the design and the concerns. So go and have a read of that. Go watch those, and you'll hopefully find some answers. And thank you, Peleus, for answering that in text as well. So there's 42 of you watching, which is lovely. Do any of you out there have questions at this point around what it is that we've done? When I say we, in this case, I really mean I. Even if the questions are C# specific, if the questions are .NET specific, if they're like, hey, why the hell would you do such a thing? They're all valid questions. Some of them I may postpone to other streams, depending on what that question is. But if you have them, ping them into chat right now, because I've got 9 minutes before I put a kibosh on the rest, because I'm stopping these streams at 2 hours at the moment. Should probably add some more detailed info about the project in the description. In the description of the stream. Yeah, that's probably a good idea. I like that idea. I will add that. Oh, it's the first. It's Patreon payday. Oh, is it? Winning. Someone surreptitiously told Atwolf to mention Patreon. Patreon.com/ojreeves. Don't feel obliged. Just got your receipt of payments. Excellent. Does that mean you're paying or you're getting paid? Or both? Because that's cool either way. Maybe I've got mine as well. Let's have a look. Nope, I've got a DigitalOcean invoice. Yay me. Paying me. You... What? Hang on. I didn't know that you were a Patreon supporter. Did I? Man, I feel like an absolute jerk. That's right, you are too. I did not know that. I did know that, but I've forgotten because I'm an idiot. But you're a legend. Thank you very much. Any reason for starting at TLV? I imagine because communicating is the thing we need to achieve. That's a good question. So there are 2 reasons why I chose this. First of all, it seemed like a small enough piece with a known set of inputs and outputs that we can play with. And I really wanted to get something together that we could sort of build off, and then from there start refactoring, like putting stuff in the appropriate files and all that sort of thing. Something that was repeatable, something that we can unit test as well, which would be good. So I think on next stream, what we'll probably do is look to serialize the packets in the other direction, so that we can go from a abstract data type object graph in memory and say, right, serialize this to a binary writer and end up generating packets as well as being able to read them. So it seemed like a nice sort of condensed area to work in. It meant that we could dive into some code fairly early on, because I know a lot of people have been asking, when are we going to get to some code? So that's kind of nice. And it absolutely is a really core part of being able to do anything with Meterpreter. So it did seem like a logical choice. Who would get any value from this code? Like, who is the utility for? Common Enterprise layman's. Okay, so Wolf goes Naya. This code will end up being part of an implant or a rat or an agent that runs on a victim's machine when a penetration tester / fake bad guy owns them. So hackers will use it. And so most of the people on stream right now are people who are vested in the security field and may or may not make use of this utility already, at least in a native stance. We're just building another implementation of it that will run inside the CLR. Where do you see the next logical step will be parse comms? That's a really good question. I would say that we will go from TLV up to general session management, and we'll start putting a structure in of what a Meterpreter session server looks like. So we'll probably have a server object. The server object is what gets invoked when Meterpreter starts. That thing will handle scheduling, it'll handle threads, it'll handle the reading of packets off the transport wire, it'll dispatch the packets to the extensions, it'll be the thing that maintains the extensions, you know, all of that sort of stuff. So does that answer your question? That's probably where we'll go. We'll go from TLVs back up to the thing that is able to invoke the parsing of them and the management of all of the things that kind of relies on that. Blue team represent. That's right. Parody is here because he wants to know what this smells like, so when he sees it on his network, he knows how to stop it, which is awesome. Now, this toString stuff that I've put in as part of the packet in TLV, that's purely because I'm lazy, and it means that later on we can like debug it. But I will change this so that it is conditionally compiled out. So if debug and if. So that should still be compiled in. But if we change this to release, it's now compiled out. So that's basically what we should do with this kind of stuff, because this kind of code is something that's detectable. Does that make sense? Para, yeah, that's right. Yarra rules for the win. We're all here for the same reason, and that is to improve security across the board. I have a digital crotch punch. That's funny. Do you think there is a significant work to be done on the Metasploit side for it to understand the new Meterpreter, or is our job to conform to rules already in place so only minimal changes are required? It will be the latter. So the stuff that we need to do on the Metasploit side is make it aware of the fact that there is a .NET platform that it now needs to support. So there'll be a platform that isn't just Windows. There'll be an architecture that is .NET 2 and an architecture that's .NET 4. And so we need to load the right extensions based on that architecture in the same way that we would with a 64-bit native Meterpreter. And then we have to create stages and that sort of stuff. So, but all of the TLV related wiring behind the scenes, we should not have to touch that. There are probably a bunch of other things we are going to have to change because the platform will remain Windows, but the architecture will be .NET 2 or .NET 4. And then it gets kind of gets nuanced, right? Because is the architecture .NET? Is the platform .NET on Windows? Does the platform include the CLR? Should the CLR mention whether it's Windows or not, or just the version? And then because behind the scenes, even though this is compiled to any CPU, we are technically running either 32 or 64-bit. So does that become the platform? These are questions that we need to answer. Will that be related to Metasploit making assumption or options chosen by the operator? That'll be Metasploit making those assumptions. Will it run on mono? Does Windows matter? I would say that a good chunk of what we're going to be doing will be specific to Windows. So I would say for now, assume Windows. So you mentioned sessions. I would have thought that the client side, Metasploit would be in the place for it. Yeah. So when I say session stuff, I'm talking about the metadata associated with the current session from a Meterpreter context. So that means maintaining the list of transports, handling configuration that comes in off the wire, managing session GUIDs, managing pivots and things like that. So when I say session, I mean the lifetime of a current Meterpreter session, including making sure that it expires and shuts itself off when things have timed out. Hopefully that answers your question. Gombos, it'll be like Windows.NET Meterpreter. So well, I think what it'll probably be is .NET 2.0 / Meterpreter / reverse TCP. .NET 4.0 / Meterpreter / reverse HTTPS. You really should do an updated Patreon post now that you're running these streams. Your last post on there was November. Yes, that's true. I really should do that. I agree. So that other people can see that. Thank you for the suggestion. Metadata about that particular session is state tracking. Yes, exactly that, Peleus. Exactly that. Now, please keep the questions coming. I am going to sign off now because we are pretty much bang on my 2-hour limit. I'm trying to be very good so that I don't burn myself out. But I'm very grateful that you all came along and joined in. thanks for the questions. Thanks for writing, and please keep them coming. And I'll see you guys on Discord or on the Twitters and all of that sort of thing. So cheers. As always, I really appreciate the support. Shout out to another couple of patrons that did appear in the last 24 hours. Very much grateful for any of the support that you guys are happy to give to me. So thanks very much. You're all legends. Much love. Peace. All that sort of stuff. Actually, let me just do the pop over to my face. Close up because you all love me. But yeah, thanks a lot. I'm still having a great deal of fun doing this stuff. I'm hoping that you can compare and contrast this stream to the last one to see sort of where you want the interaction to be. I kind of went from too much interaction and too many chiefs through to today where I was like, right, I'm just going to bash it out and I want you guys to enjoy it. Hopefully we'll find the right spot along the way for it. So feedback, as always, is appreciated. So right, I'm finishing up. Lots of love to you all. Take care. Until next time, be good.